You've got 3 virtual networks in Azure and a data center back at the office, and you need them all talking to each other securely. Azure gives you 3 connectivity primitives that people constantly confuse: virtual network peering, the VPN Gateway, and ExpressRoute. They are not interchangeable. In this video, we'll build one hybrid hub and spoke network end-to-end, and at each layer I'll show you which primitive to reach for and why. By the end, you'll know exactly where peering stops, where the gateways begin, and how to pick between a VPN tunnel and ExpressRoute based on bandwidth, latency, and cost. Here's the architecture we're building. A central hub virtual network holds shared services and the connectivity gateways. 2 spoke virtual networks hold the actual workloads, kept isolated for blast radius and governance reasons. The on-premises network sits outside Azure entirely. The pattern is deliberate. Spokes never connect directly to on-prem. All cross-boundary traffic flows through the hub, where you place your firewall, gateway, and inspection. This is the standard Microsoft hub-and-spoke topology, and it's the foundation for landing zones. Each connection in this diagram uses a different primitive, and that's the whole lesson. Start inside Azure. To connect each spoke to the hub, use virtual network peering. Peering links 2 virtual networks over Microsoft's backbone with near zero added latency and full line rate bandwidth, because there's no gateway in the path. Create a peering from hub to spoke and another from spoke to hub. Peering is not transitive, so both sides must exist. Critically, enable allow gateway transit on the hub side and use remote gateways on the spoke side. That lets the spokes reach on-prem through the hub's gateway later, without each spoke running its own. You pay only for inbound and outbound data across the peering, typically around 1 cent per gigabyte each way, but check current pricing. Now connect the data center. Option A is a VPN gateway. You deploy a gateway subnet in the hub, create a VPN gateway resource, then a local network gateway describing your on-prem device, and a connection that establishes an IPsec tunnel over the public internet. Pick a SKU based on throughput. The VPN GW1 tier gives you roughly 650 megabits per second, scaling up to several gigabits on higher tiers. It's quick to stand up, costs tens of dollars a month plus data, and supports active-active for resilience. The trade-off is that you're riding the public internet, so latency varies and throughput is capped by the SKU. Option B is ExpressRoute. Instead of a tunnel over the internet, you order a private circuit from a connectivity provider that lands at a Microsoft peering location. In the hub, you deploy an ExpressRoute gateway, create the circuit, then link them. Traffic never touches the public internet, so you get consistent low latency, higher bandwidth from 50 megabits up to 100 gigabits, and an availability-backed service level agreement. The cost is real, a monthly port fee plus provider charges, and provisioning takes weeks because physical circuits are involved. Choose the metered or unlimited data plan based on your egress volume, and verify current rates in the docs. So which one? My rule of thumb: start with the VPN gateway when you need connectivity fast, your bandwidth needs are modest, and encrypted internet transport is acceptable. Move to ExpressRoute when you have steady high-volume traffic, latency-sensitive workloads, regulatory requirements against public internet, or you need a bandwidth SLA. A common pattern is running both. ExpressRoute as primary with a VPN gateway as automatic failover, which gives you the private path plus a cheap insurance policy. Inside Azure, none of this changes peering. Peering stays the answer for VNet to VNet every time. Now confirm it actually works. First, check effective routes on a spoke virtual machines network interface. You should see routes to the other spoke and to on-prem, learned via the hub gateway. Use Network Watch's connection troubleshoot to test reachability from a spoke into the data center. For the gateway itself, confirm tunnel status shows connected, and that BGP is exchanging the expected prefixes. Finally, run a real throughput and latency test end-to-end, and compare it against the SKU or circuit you provisioned. If routes are missing, the usual culprit is gateway transit not being enabled on the peering. Here's the mental model to keep. Inside Azure, VNet peering connects virtual networks with no gateway, no extra latency, and per gigabyte pricing. To reach on-premises, you add a gateway in the hub, a VPN gateway for fast, encrypted internet connectivity, or ExpressRoute for a private circuit with higher bandwidth and an SLA. Peering carries spoke traffic to that gateway via gateway transit. Your one actionable takeaway: build the hub and spoke skeleton with peering first since it's cheap and instant, then layer in VPN or ExpressRoute only when you actually need on-prem reach. Because SKUs and pricing shift, confirm the current numbers in the Azure docs before you commit. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.